Right, what we're going to look at first of all with amines is just drawing them, naming them. So you notice that I've got this general formula of RNH2. That's actually the general formula for a primary amine. Alright, so they actually have a couple of general formulae. So you've got primaries, secondaries, and tertiaries. Alright, so where each R is a different length, or they can be the same, they are carbon chains. If R is an H, then of course it goes back to 1, 4. If R1 in the primaries was an H, what molecule have we got? So NH3, what is that? It's a molecule we should know.
Ammonia.
Ammonia. So you'll find their naming is very similar to ammonia salts. So when we do the reactions of these, for example, the acid-base reactions, because they are bases, you're going to start seeing things and go, oh, that's just like naming an ammonia crystal or an ammonia salt. And that's exactly right. So when we look at reactions, you're going to see a lot of similarities between amines and ammonia. The shorter the carbon chain, the more it acts like ammonia, basically. Right, so here we've drawn up, we're challenged to draw up and write up as many C4H11N isomers as we could come up with. Very quickly, you guys did very well in noticing you put the nitrogens in the middle. I'm just going to quickly go through. Notice that the primary, secondary and tertiary is different to in haloalkanes and alcohols. Here, it's all about the nitrogen. It's how many carbons is the nitrogen bound to. So keeping that in mind, that will help make our naming a little bit easier as well. So it's how many carbons is this bound to. Now in our rules for naming things, we tend to look at our longest carbon chain first. And again, this is the same. Our longest carbon chain here has got 4, so it's going to have bute in its name. There's no double bonds, so it's going to have butane in its name. And it's an amine, so it's just butanamine. The amino group is on the number 1 carbon. Okay, so it's on the end, so it's on a terminal carbon, so it's 1-butanamine. Or, this is an equally correct name, it's 1-aminobutane. Both names are equally correct for this. But the key thing is the 1 to say which carbon it is on. We number carbons. So here we can see that it's on number 2. So the possible names for this are either 2-butanamine, because we've still got 4 carbons in a row, or 2-aminobutane. Both are equally correct. I'm going to use the aminobutane way. The reason I am is because I'm a biochemist, so I like the idea of, if I had an acid group on it, it'd be something something or other oic acid. So that amino acid comes from this. Here we can see that our carbon chain is only 3. So I have got, this has to be carbon number 1, so this has to be carbon number 2. The side chain's got 1 carbon, so it's 2-methyl. 1-aminopropane, because you've got a carbon chain of 3. Alternatively, it could be 2-methyl, 1-propanamine, or propan-1-amine. Some see why I prefer the amino at the start. Less of a tongue twister, basically. And here, same idea. We've got our largest carbon chain is here, so everything's bound to this carbon, which is number 2, 2-methyl, 2-aminopropane. Using these names for the reactions sometimes can be a bit tricky, but I'll get to that when we do the reactions. So that's why it's good to know both names. Okay, so here, 2-methyl, 2-propanamine, for example. Right, what happens when your side chain is bound to the nitrogen, not bound to a carbon? How do you tell the difference? I think we can all see the largest carbon chain here is 3. So therefore this is one aminopropane. Down to number 1 carbon, it's got 4 carbons. So it is 1 aminopropane. How do I account for the CH3 group? What do we call a CH3 group? Methyl, good. So it must be methyl 1 aminopropane. But that doesn't tell us what that amino group is bound to. It could be bound to that, and it would still be methyl aminopropane. How do I show that it's bound to the nitrogen, not to the carbon chain? The way that we do this is we do a capital N and slopey writing next to it. So you might have seen on some of your antibiotics or other drugs that you might have to use for getting better, you often see N at the start of names. These are amino derivatives or amide derivatives. We'll get to amides later in the topic. This means the methyl group is bound to the nitrogen, and this tells you the rest of the compound is 1 aminopropane. So when you're drawing it, you draw your 3 carbons in a row, put an amine, so nitrogen, on the number 1 carbon. Then on the nitrogen, you'd also put a CH3, and then you put a hydrogen to finish off the shape. Okay? So let's have a look at this one. If we have a look at it, my longest carbon chain is here. Again, it is aminopropane. But which carbon is it bound to? 2. So it's 2 aminopropane. Whoops. Let's try that again. Again, it's got a methyl group on it. And that methyl group is bound to the nitrogen. So what do I put at the start of this name? N. Awesome. Okay, N, methyl, 2 aminopropane. Okay, here we go. This one gets a little bit trickier. You've got aminoethane, haven't you? Or you could class these as being 2 ethyl groups, because they're the same. If you've got 2 groups that are the same, we call them diethyl or dipropyl or dimethyl or whatever. So because they're the same, we've got N diethyl amine. That's one name. That's its old name. That's not the way you'd name it using IUPAC. That's what it used to be called. Okay? So I'm going to put a bit of a cross next to that one. It's not the way we want you to name it. We're going to continue with this system above. So here we've got N-ethyl aminoethane. That would be the way I'd expect you to name this. Sorry, methyl accidentally. If you only have 2 carbons, there's no need to number them, okay? Because 1 and 2 are kind of the same. Right, our last one. There's a couple of ways to call it. It could be dimethyl ethyl amine. Okay, so N dimethyl ethyl amine. Again, we're not going that way. But we have got 2 methyl groups, haven't we? Because the longest carbon chain is here. So see how this was ethyl aminoethane? This is going to be methyl aminoethane. So we've got 2 of these. How do I say there's 2 of them? Di. So we're going to say di. Whoops, that wasn't in italics. What are those methyl groups bound to? Nitrogen. So, how do I show that they are bound to nitrogen? Well, there's a wee hint in here on how it's done completely correctly. 2 N's. Well done. Both of them are bound to the nitrogen. So you have to go N, N dimethylaminoethane. So this is where their amines are a bit tricky, their naming. Okay? Classification's easy, just look how many carbons the nitrogen is bound to. So it's bound to 3, it's tertiary. It's bound to 2, it's secondary. Bound to only 1 directly, then it's primary. So that was a little bit different to our alcohols and our haloalkanes. We looked at this carbon. How many is it bound to? Okay, so there's a little bit of a difference here. Naming, we're now learning that methyl and ethyl and all those other side chains can be bound to things other than the carbon chain. To show that, we use in italics the element that it's bound to say where we find it in the compound. So in this case, because we're doing amines, we use the nitrogen. Are there any questions before I turn that off?